You must have all heard the terms metals and non-metals. Can you look around and see if they exist in your surroundings? What is your table made up of? Aluminium or wood? What about the phone or the laptop you're viewing this video on? Is it made up of metals and non-metals? As a matter of fact, it is. Almost everything around will be made up of either a metal or a non-metal. But how do you differentiate between the two? Is it as easy as the difference between the two colors black and white? Well, for that, let us look at the physical properties of each category in detail. Let us take for example the ornaments. Any of the ornaments will do. What do you have to say about them? You will observe that most of them are made up of gold or silver. Let us look at them closely. Do they have a shining surface? Or even the aluminium utensil in the kitchen? Does it shine? Of course, both gold and aluminium have a certain shine. Do you know what this shine is called? Well, it is called luster, and as both gold and aluminium are metals, this is known as metallic luster. Now we know that metals have a metallic luster. Now if the utensil drops on the floor, does it break into parts? No, right? That is because metals are generally hard in nature. However, this hardness varies from metal to metal. A very thin plate of gold, for example, can be easily broken with a little pressure. Plate? Did I say plate of gold? How do you think huge aluminium sheets are made? Or sheets of copper or zinc? If I take a hammer and beat them, will they break or will they turn into sheets? It is the amazing property of metals to be beaten into sheets. And we call this property of metals as malleability of metals. Most metals can be beaten into thin sheets. Do you know another important property of metals? Have you ever seen copper wires or thin gold wires used to make jewelry? Metals, by nature, can also be drawn into wires. Do you have any clue as to what this property is called? It's called ductility of metals. The ability of metals to be drawn into wires is called ductility. There is an amazing fact I want you to know. A single gram of gold can be drawn into a 2-kilometer long wire. Isn't that amazing? Well, there are some more interesting properties of metals which we will learn in our next lesson. We learned 4 properties of metals in our earlier video. Can you name them for me? Metallic luster, malleability, ductility, and that they are hard. These were the 4 properties, right? Can you think of some more properties of metals? Metal utensils are used for cooking, aren't they? Why do you think they're used for this purpose? Which energy do we need to cook food? Heat energy. Correct. We need heat energy to cook food, and metal utensils are good conductors of heat. They help transfer heat evenly through the entire surface and provide even heating. No doubt, most metals are known to be good conductors of heat. Do you know the 2 best conductors of heat? They are silver and copper. 2 other metals like lead and mercury are comparatively poor conductors of heat. Electric wires were also made up of metals, right? Why is that? It's because they are good conductors of electricity too. If we have a battery and a bulb connected in a circuit with a metal wire, you will see that the bulb will glow where the switch is closed. And because they are good conductors of electricity, they are coated with rubber-like material. This rubber-like material acts as an insulator which protects us from being electrocuted if we touch the wire by mistake. Do you know any other property of metals? What happens when we strike a metal on a hard surface? Like utensils banging against the sink. Can you hear a sound produced by metal? Yes, this is another property of metals. We can call metals as sonorous, meaning they produce sound when hit against a hard surface. No doubt, school bells, church bells, or the bells in a temple are made up of metals. If these are the characteristics of metals, What do you think will be the characteristics of non-metals? In simple words, just the opposite of metals. In a nutshell, non-metals like carbon, iodine or sulfur do not have luster. They do not shine and are brittle in nature. What do we mean by brittle? They cannot be beaten into sheets or wires as most of them turn into powder when hit by a hard substance. Non-metals can also be gases like oxygen, hydrogen or solids like carbon, sulfur, etc. Do you know of any non-metal in the liquid state? Bromine is the only non-metal which is in the liquid state. Non-metals do not conduct heat or electricity, and they do not produce that sound when hit against a hard surface. This means that they do not have the property of sonority. So isn't it easy and simple to differentiate between metals and non-metals only on the basis of their physical properties? Wait, but mercury is a metal in liquid state at room temperature and bromine is a non-metal in a liquid state at room temperature. How do we differentiate between the two based on physical properties? We can say that all metals are solids at room temperature except mercury, and all non-metals are either solid or gaseous except bromine. Well, this is not it. There are a few more exceptions that break the physical appearance norms of metals and non-metals. For example, most metals have high melting point, which means that they need a large amount of heat to melt. But look at the two metals gallium and cesium. They melt when you keep them on your palm. We must say then that these two metals have a very low melting point. Look at another exception in non-metals. Iodine, for example, is a non-metal, but it has a property of the metals. Can you point out which property I'm talking about? Correct, the luster. Iodine has shine or luster, which is technically the property of metals. Take another example, carbon, for instance. What is carbon? Is it a metal or non-metal? Yes, carbon is a non-metal, but look at diamond or graphite. They all come from carbon. They are known as allotropes. The different forms in which carbon can exist are called its allotropes. Let us look at the allotrope diamond of carbon. It is known as the hardest substance and has an extremely high melting point and boiling point. Aren't these the properties of metals? But it is surprising that diamond is an allotrope of carbon, which is non-metal. Diamond too is a non-metal which strongly exhibits the properties of metals. Now that we know of so many exceptions, do you think it's easy to differentiate between metals and non-metals based on their physical properties? I doubt that, but don't worry. There is another way out of this. It is to differentiate the two based on their chemical properties.
Welcome back, students. Students, today we are going to look at a comparative study of metals and non-metals. Well, you have already seen the differences in physical properties of metals and non-metals. Here I am going to just summarize all the physical properties and we will see how are they different from metals and non-metals. This lesson is particularly going to be really useful for you for the revision purpose of differences between metals and non-metals. So let's begin. Well, to begin with, we see here that metals and non-metals, they can be differentiated with their first physical property as metals are malleable and ductile. We have learned that metals are malleable and ductile. They can be converted into thin sheets and wires. Next to this, if we talk about non-metals, they are neither malleable nor ductile. They are rather brittle. So if you try to hammer them, they will simply break into pieces. Easy? Next difference is that metals here are good conductors of heat and electricity. Whereas if we talk about non-metals, they are poor conductors of heat and electricity. Although there is an exception, which is graphite. Graphite is a form of carbon which is considered to be a good conductor of heat and electricity. Okay, so don't forget the exceptions. Third difference is that metals are lustrous. Yes, they have a very beautiful shine on them. Whereas if we talk about non-metals, they are not lustrous or shiny. They are usually dull. An exception can be graphite again, which has somewhat some shine on it. Similarly, iodine also has some shine on it. So these two can be exceptions to the luster property. After this, we will speak about the fourth property, which is metals are strong. They have high tensile strength. I told you already that metals are strong. That is why they are used to build those high bridges, those strong crane machines, the railway tracks, etc. On the other hand, we see that non-metals are not strong. They have a low tensile strength. Well, an exception to these, we see that metals are strong usually, but we have metals like sodium and potassium which are not very strong. They are soft in nature. Similarly, if you talk about non-metals, diamond is the hardest substance known, which is a form of carbon again. So don't forget about the exceptions. Fine? Okay. Moving forward, the fifth point. Metals are sonorous. Well, we know, you remember the temple bell, right? Yes, so they make a ringing sound when struck. Then we have non-metals which are not sonorous. They do not make a ringing sound when you strike them. Okay? Next to this, talking about the next property here, we have metals are generally hard. Like I told you, they are strong. We can say metals are generally hard. Then we have non-metals, which are, if we talk about, let's say, solid non-metals, they are quite soft. Again, we see that metals are generally hard, but metals like sodium and potassium are soft. We have mercury, which is a liquid. So these are not hard. Coming back to non-metals, here we see that solid non-metal, again, such as a diamond. Diamond is really hard, right? So, talking next, we have metals which are mostly solids and non-metals which can be solid, liquid or gases. Again, I repeat, an exception to solids. We have mercury, which is a metal, but it's a liquid. So this was a quick revision to all the physical properties that we have learnt in detail. Now it's time for practice. Ready? Great. First question we have is, if iron is a soft metal, true or false? If iron is soft? No. Iron is a hard metal, right? Then we have next question as, non-metals are lustrous, which means that they have a very beautiful shine. Do they have it? No. Most of the non-metals are non-lustrous. So always remember, students, if they ask you about a general question, then don't think about an exception, because they are mostly asking a general question. Most of the non-metals are non-lustrous. Maybe one is, but that will not be counted here. Okay, so keep this in mind. Next, we have copper wires are used in electric appliances. Is it true or false? Copper wire are used in electric appliances. Well, you get such questions, students, to first understand that if you know what is the requirement of an electric appliance. The requirement here is that if something will conduct electricity, that only we will put in the electric appliance, correct? That kind of wires will only be used. So now the question arises, if copper wires can conduct electricity or not? Well, they certainly can. Why? Because they are metals. Hence, this is true. Got this? Easy, huh? Next, we have carbon can be beaten into thin sheets. True or false? Now, can be beaten into thin sheets means they are talking about a particular property. Can you recognize that? Great. Yes, it is malleability, which means they're asking if carbon is malleable or not. Now, to understand this, you must remember that carbon is a metal or a non-metal. And carbon is a, yes, non-metal. So we know that non-metals are non-malleable, which means they cannot be beaten into thin sheets, which means that this is false. So I am trying to give you a number of questions here, students, so that you know what is the approach to them. Next, we have oxygen and hydrogen are gaseous non-metals. Well, we certainly know about oxygen here, and hence we can take a guess for hydrogen too. So hydrogen and oxygen are both gaseous non-metals, which means this is true. So here we have understood and summarized the differences between metals and non-metals. Now you know what kind of questions can be asked and you know the reasoning behind.
Gold, copper, aluminum, mercury, lead, etc. are few metals which are used in a lot of things around us. Carbon, sulfur, hydrogen, nitrogen, chlorine, phosphorus are few non-metals which are used in various day-to-day life things. In this video, we will learn different uses of metal and non-metals. Uses of metals. Metals such as iron have high tensile strength and thus used in making houses, bridges, engine parts. Copper is good conductor of electricity and thus electric wires are made from it. Copper is good conductor of heat and various utensils are made from it. Because of its durability and malleability, it is used in making coins and statues. Silver and gold are lustrous metal and thus used in making jewelry, in decorative items, and photography. Mercury is liquid at room temperature and changes uniformly with the rise in temperature. This property makes it useful in thermometer and barometer. Thermometer is used in measuring temperature whereas barometer is used in measuring atmospheric pressure. When temperature or pressure rises, mercury expands and rises in the thermometer or barometer. Aluminum is lightweight and used in aerospace industries. In planes, aluminum is used in the form of alloy of magnesium. Aluminum is also good conductor of electricity and it is ductile too. Thus it is used in making cables and wires. Lead is used in automobile batteries, X-ray machines. Now let us discuss uses of few non-metals. Carbon is a non-metal. Diamond and graphite are two forms of carbon that are found naturally. Diamond is a well-known jewelry material. It is also the hardest naturally matter and is used in cutting glass and in grinders. Pencil leads are made from graphite. Sulfur is used in the manufacturing of gunpowder and vulcanization of rubber. In vulcanization, rubber is heated with sulfur and other materials. After this process, elasticity, resilience, tensile strength, viscosity, hardness and weather resistance of rubber increases. Phosphorus is used in matches, rat poison etc. Matchsticks contain phosphorus and chlorate which, on friction, acts like a explosive and help wooden stick to burn. Nitrogen is base material of proteins which are used by living beings for growth. In plants, ammonia is good source of nitrogen. Ammonia is made from nitrogen non-metal. Chlorine is helpful in killing dangerous microbes and thus it is used as a bleaching agent and in sterilizing water. Sterilizing is the process in which harmful microbes are removed from something. Hydrogen is used as a rocket fuel and hydrogen flame is used for cutting and welding purposes, as well as a reducing agent. Reduction is the process by which pure metals are obtained in a chemical reaction.